Hello and welcome to another lesson on functions, and in today's lesson we will discuss what are inverse relations. So what are inverse functions? Let's talk about it first. So all those functions that can undo each other are called inverse functions. And how can we find inverse functions? We can simply find inverse functions by switching the dependent and the independent variable given in the function. When we do that, when we switch them, the domain and the range are also interchanged. So what is it? So if we talk about any function, the domain of your original function would be the range and vice versa for your inverse function. Let's look at a couple of examples. In this first example, y equals 4x plus 3. Y is the dependent variable and x here is the independent variable. And when we find its inverse, we find its inverse in which we change the dependent and the independent variables. You can see that here. Same is true for the second example as well. So how can we identify inverse function? So it is important to note here that every inverse relation is not a function. Okay, and we first have to check that if we have an inverse relation, whether it is a function or not. If our inverse relation is a function, then only we can use the function notation for it. Otherwise, we cannot use the function notation for our inverse relation. So how can we check? Graphically speaking, if you have to check it graphically, then this condition has to be satisfied, that which says that the graph of the inverse function is a reflection on the line y equals x. What do we mean by that? If we look at it graphically, let's say if you have a function f of x is equals to x square, and you say that whether its inverse x equals to y square is a function or not. Now you have to draw a line, this line, black line, that is at y equals to x. Okay, this line is basically drawn as a line of reflection at which x and y values are equal to each other. And when you reflect this, your original function along this line, and you get the reflection of original function, then you say that your inverse function is also a function. But you can see that this is not the case here. So we can clearly see that x equals to y square is not a inverse relation or not an inverse function of our f of x is equals to x square. We can also see this algebraically, like if we have f of x is equals to x square, and if we have to find its inverse, x is equals to y square, x is equals to plus minus under root y, and we get x is equals to plus under root y and x is equals to minus under root y. So we can clearly see that our condition that one value can only have one value of y is not satisfied here, because one value of x is having multiple values of y. So algebraically it is also true that this inverse relation is not a function. What about the domain and the range? If we talk about the domain and the range for our original function, the domain is a set of values it can take without getting undefined. So the domain is all the real numbers. And what about the range? The domain is also the all real numbers. It can be all the real numbers, but the value it produces is always greater than equal to 0. Okay, because the value it produces will always be positive. Now in terms of its inverse, in case of inverse, the domain becomes range and the range becomes domain for our inverse relation. So let's take a look at a couple of more examples to see what is going on here. So in this case, our original function is f of x to x plus 3, and let's see what its domain is. But its domain is all the real numbers and its range is also all the real numbers, because there is no value at which the function becomes undefined, and it can produce all the values as well. So what about the inverse function? Is this inverse function a function or not? Yes, it is a inverse function. Because why? Because when we see it graphically, we will get to know that along this line y equals to x, we have a reflection of our original function f. That is why we say that this inverse function f of an inverse of x equal x minus 3 by 2 is a inverse function of our original function. And in that case, if we have an inverse function, the domain of our function, original function, becomes the range, and the range of our original function becomes the domain. Because if you see, the original function is f of x 2x plus 3, the x values become the y values for our inverse function, and the y values become the x values for our inverse function. So this is it for this lecture, and thank you for joining.